Welcome back to my channel, Shasha AI World. This is your friend Kannan Nova, data scientist, masters in data science from US. Share the knowledge, gain the knowledge. Knowledge is alone permanent. This video is a part two of loop engineering and harness engineering. This is a final part. First of all, what is harness engineering? In part one, I already explained, but I am going to explain one more time over here. This is a very, very important one in LLM application because uh, if you develop without any harness engineering, then application is POC. It's not production ready. So you have to give the environment to LLM. So that LLM environment may be safe, safeguard, guardrail, AI governance, evaluation, observability, validation, retry, everything. Right? So you have to say, based on your company domain, enterprise domain, your whatever functionality, based on that, this is a rule, this is a policy, this is a safety guard, guardrail, everything you have to give, make it and give to LLM so that LLM will work with that environment. So you are like a harness agent. We call infrastructure and runtime. We have to give around the LLM. We have to make so that the LLM will work. AI agent will work with that environment. Let's see the Python code demo for harness engineering. First demo is, as I said earlier, it's going to be a no harness in my demo. Okay, like a simple chatbot. User puts the prompt, LLM receives it, and it generates the new output content. Okay, that's it. The next demo, I'm going to show Python code which is going to have harness engineering, like validation, but it's not like if condition validation. Okay, harness engineering validation. Okay, but it can be validation, observability, safeguard, any harmful content we can filter out. We can apply governance, regulatory complaints, everything. All are harness engineering. But for demo, I'm going to show simple validation, how to apply harness to implement the validation. Let's see the no harness engineering demo first. I'm importing all necessary packages. First, we need LLM. Okay, brain, right? So from OpenAI, I'm going to import OpenAI. Then I need to bring the key to the Python code, right? This is my file. From dot, environment, then OS, import OS. First step, I got to load the key. Load the key. Key is stored in .env file. Now, then I have to create LLM client. LLM client. Okay. Then I have to create the question, right? Question, like I'm going to ask a simple question. So question is, what is the capital of France, right? Okay. Then I'm going to give another instruction, say that answer in exactly. You can write anything. answer in exactly one sentence. And no. Okay, that's it. My question. Right now, question is ready. Client is ready. Now I got to invoke the client. Client dot responses dot create. I got to mention the model name. I'm going to use a GPT 4o mini. Then I got to pass the input. And there's an input question. Input equals to question. That's it. I'm going to use only 2 parameters. Right? Yeah. Now this has to be stored in one variable. It will be a response. Okay. Then print the response. That's it. Let's run this code. See, I got the output. But it's a whatever output comes, I'm showing to end user, right? This is not correct approach or not proper design, right? It's not best patterns and practices. So we should apply the harness to this application. So where should you put the harness? Like a response comes back, you have to apply the harness, but the harness should be before sending the details to LLM. Okay, but harness can be validation error, validation checking, uh, can be observability, like output controlling output, or like applying a policy, regulatory complaints, everything. Right? So let's see the another demo. There I am going to apply the harness engineering in my Python code. My previous demo shows no harness, right? No harness implementation means simple AI chatbot gets input, generates output. LLM is simply responding back, and we are showing everything to end user. Okay, without applying any harness capabilities into that application. Now I am going to show the harness, how to implement harness capabilities into your Python code, into your application. Okay, let's see the diagram. This is a simple diagram. The left side is a no harness. Here is a harness engineering or a harness agent, right? So user harness we are applying before sending that the details to uh, agent. Agent is nothing but combination of LLM tools memory, right? So then we are applying the validation or harness application rules, everything. Okay. First introducing harness, then that will implementation will happen once we get the data back, response back from agent like LLM or tools. We apply the harness rule. Okay. So this is a main difference. Okay, you have to know how to enable the harness into your application. It's not a flag enabling. You have to implement the code. Okay. So in my demo, I'm going to show some like 3 business rules. Okay, I'm going to implement. Okay, not only business rules, whatever harness capabilities we can enable. Okay, like security, runtime, uh, evaluation, observability, like output validation, and control the output, retry, loop controls, everything you can try. Okay, uh, in my business rule, or this code has 3 business rules. First one is saying that response cannot be empty, means I should not show the non-empty response. Okay, and second one is response should be less than or within 50 uh, uh, words. Okay, like less than 50 words. That is a second rule. Third rule is, I'm saying, you should not give false commitment, right? Like it's a delivery based system, like a transport or delivery. Then I should not say your package will arrive tomorrow, you will get it by tomorrow. I should not say that way, because we don't know. Okay. And another one, guaranteed delivery, you should not say that. This kind of response should not be visible to end user. Okay. So let's see, I'm going to run honest engineering. This is okay. In my code, what I did, I'm imported all the necessary packages. Then I'm loading the LLM key, okay, from .env file, and I'm saying this is a business rules, three business rules. First one is a max 50 words, okay. Yeah, this is a business rule. Yeah, and three times a try, and come out from loop. That's what. That's another business rule. Okay, and the third one should not be empty and should not have any false or hallucinated answer. Right. That's all business rules. So my question is, end user is asking, where is my package? Right. They're saying is my package has not arrived yet. Right. So what should I do now? Like they're asking to customer center or a chatbot, right? Then this is a LLM code, ask LLM, right? LLM, you saw my previous code, like create client and pass the LLM model and input, right? Input, I'm saying you are a customer support assistant. Customer question is this, and provide a short and helpful answer. Do not invent information, means don't hallucinate or don't give your own answer. Okay, that's the meaning. Okay, if you don't have enough information, tell the customer to contact customer support. That's a way we have to give the system answer, right? Like okay, okay, that's what doing it LLM. Okay, so the LLM is okay. Now validation rule is there. Okay, validation rule, what we are doing, if answer is empty response, and we are saying validation failed, false. If word count is whatever max count 50, more than 50 and less than, we have to make sure that response is less than 50 or within 50, right? That's what we are doing it. Okay. And rule uh, three three is like any dangerous hallucination patterns, right? Harmful content we should not give back to end user, or apply our governance or compliance, right? Any HIPAA compliance, like sensitive info, everything we can apply. But my case, I put it, I don't want to give any false statement, false commitment, right? Like, yeah, package, you definitely you'll get it tomorrow. I should not say that. System should not say that way. And the guaranteed delivery. These are okay. That all. This all okay. If none of these three are false, then comes to true. Then we are giving response positive validation. Honestness, basically. Okay. Okay. Now I'm going to run the harness. Right. Run the harness. Three attempts. Three loop is max is three. Right. First inside loop, for loop. What I'm doing, calling LLM, ask LLM with question. Uh, then once we get the response back, answer, then we are doing validation. Just now we saw that validation response, right? Let's go to validation. Yeah, this is three validation rules. Okay, then validate that and get the true and reason for that. Whatever, true or false. Okay, then reason is coming. If it is valid, uh, then we are saying harness accepted. False, we are saying that try one more time if it is until max loop reached. Okay, then return unable to provide the validated response. Okay, this is what harness is. Okay, final answer, we are printing it. Okay, let's run the code now. If you have any doubt about code, please let me know, or comment. If you want the this code, go to my repo, GitHub repo, and download it and customize according to your need. Okay. Okay. See, first attempt. Yeah, it says harness accepted and response we got back, right? Yeah. It's saying sorry to hear you, all kind of things. Okay, and giving every all response this way. If you see this count of these words, now you know the harness engineering and loop engineering. If you implement both concepts or patterns or capabilities into your application, LLM application, any AI application, then your application is production ready, enterprise grade application. Now we are summary, right? So we know loop engineering and harness engineering. Please try to implement into your application. Okay, I'm keep saying that AI is an opportunity, upskill early. Otherwise, AI developers will replace you. Okay, my demo shows harness at response, means output side, right? After AI agent or LLM generates the output, I am applying harness. But real projects or enterprise applications, LLM applications, we apply everywhere. Input side, output side, processing time also. Like as soon as we receive the input, we apply harness. Like we check the input content, any harmful, any filter, any PA, everything. Then after that, while calling LLM, while calling MCP or a tool call, you need to do authentication. RBAC you need to check. These all are harness. Okay. So then while processing also, do you need to apply harness? Yes, we have to do that too. Then output side. So so it's not necessary always to be output side. Okay. We have to apply wherever possible. And previous video I explained loop engineering, how important, right? Loop engineering is into LLM. This is around the LLM. This is a simple uh, difference. Like loop engineering is you are asking LLM to work very smart way. Okay, if error happens, you go and try it. I am not satisfied with your AI agent output. I will ask to do research again. Yeah, but harness is not like that. Is I'm giving infrastructure and environment to uh, runtime to you. You have to work with these two artifacts, right? That's harness engineering. I hope you got some idea about loop engineering and harness engineering. Try to implement these capabilities into your project. Please like, share, subscribe, comment your doubts and feedback. If you have any doubts or you want me to show any new area or new topics, please let me know. I can try. Uh, Share the knowledge, gain the knowledge. Knowledge is alone permanent. Bye.